and then Cameron and Billy can take over.
So, welcome everyone. I am Billy. I am a mechanical engineer from UCF, minor in robotics.
And I'm Cameron, and I'm also majoring in mechanical engineering at UCF.
You guys see my screen correctly?
Yeah, we can see it. Yep.
Okay, so again, welcome to No Limits. This is going to be like an introductory course. If you do have experience, you're welcome to hang out, help us, give advice. There's tons of stuff that Cameron and I know how to do, and there's also tons that we don't know how. So if you have a better way to do something, or just a different way, please let us know. Please help us out. Cool. Perfect. So this first part is going to be the boring stuff, the slides, going over the different forces and different requirements that your code may need. If you want, you can pop open No Limits. This should be the first screen that you see. When you see this, you have those tabs on the button. That's how you're going to access your different coasters, your different parks, all of that stuff.
Down and broke it.
I'm going to do this because my friends are teaching it, so I should support them.
So, if you see the play button at the beginning is going to be how you actually ride the coaster once you've completed it. That's how you can see your park. That's how you can travel between your different things. The editor that is going to be how you create your park. That's where you do all of the different nodes, how you make your curves, how you make each individual coaster. Setup is for the overall program settings, music, video settings, all of that. If you want to do any settings to your specific coaster, that's going to be in the editor as well. And then help, info, quit. Cam, you want to take this one?
All right. So the first thing that you see after you click editor is opening up to a new park. If you don't see that, you can hit file and new park and then give it a name. You can also change different settings for the park, including the time, if you want to have a nighttime ride, and the weather as well. So you can have snow during your ride POV.
Where did you click to get that?
Both of these are going to be up in the top left here, where you see my mouse, the environment tab. Park settings is also going to be important. So it's kind of hard to see with this picture, but you see the gray and green background there. That's one of your views. Up in the top right here shows you different layouts or different viewpoints of your coaster. You can see from the top down bird view, the front of the coaster, back, left, right. You can see it as perspective as if you're sitting on the coaster itself, and then the track view as well. Questions so far? Cool. So up in the top left there, they had, we already did the new, that's how you create your park. For No Limits, a park is a collection of coasters or rides or environment, similar how an actual theme park would be. However, when you get into it, you can create individual coasters, which each have their own. However, personally, I like to have 4 views on my screen so that I can see the top, I can see the perspective, I can fly around as I need to. If you want to change that, you go down, you go to File, Preferences, Common, and then you get that single view drop down. It'll give you different options on how you want to set it up. As well as personally, I like to set the grid size to 5 feet, just so it's easier numbers. If you see on the boxes here, your X and Z coordinates are each going to be 5 feet.
All right, thank you for pointing that out. I can take over at least by narrating the slides if Billy wants to keep clicking through until he can resolve those audio issues. So this slide is just to show you the different tools that are available in your NoLimits2 editor. The first tab being Park, where you can set different things like the time and the weather that we showed you. And then under Coaster is where you'd be creating your individual coasters. You even have an option to import a coaster from other NoLimit2 files if you want it to be in your park. You can set different coaster properties, like whether it's a traditional steel coaster or a suspended coaster, the wing coaster, and a few different manufacturers' vehicles that are available by default in your NoLimits2 program. Then you have the track, where you'll be doing a lot of the hand building of the coaster itself. The elements for loops, corkscrews, and other complex tracks that have been built into the program. You also have supports, which are purely visual, but very many options available to you. The terrain is more for creating the layout of your park. If you want a hill, if you want a mountain that the coaster goes around, that's where you would change it in the terrain section. Scenery for trees, background rides, and a few special features that can help you during the design or during the ride POV for an alternate view, like a camera view of your coaster. And then advanced, which we won't touch on much today, but you can import 3D objects, the textures related to them, and do some things like scripting and lighting.
Test, is my microphone working again?
I can
A
hear
little
you.
better. Cool. So when you go into the individual coasters, so in here, coaster properties, you're going to pop up with these screens here. You have the different tabs that show off your different settings. So for example, the style, that's going to be how you pick your different coaster style. You have classic coasters, you have spinning coasters, you have hanging coasters. Anything like that, you can change the physical appearance of these coasters. If they're worn out, cleaner, anything like that, newer. And the colors, you can change the colors of anything that you build, harnesses, all of that stuff. This one over here with the trains is pretty important. If you see there, you have trains. Still cutting out.
Yeah, your mic is cutting out periodically.
Here, Cam, why don't you take over and let me...
All right, yeah. So we had a question in the comments. This is a good time. Is no limits used in the industry, or is it purely for aesthetic and visual purposes? So in the industry, NoLimits2 can be
my microphone
for visualizing. It can be very helpful for kind of giving a previs of a coaster that you'd be pitching to a client. At least that's what I've heard when talking with different people in the industry. And then we also have another response that it's also used for actual engineering. And that's what's so great about NoLimits2 is that it's not just about having a ride POV that looks great, but it also contains the physical information that you would have about a ride, like the speed that the coaster's traveling, the G-forces that riders would feel. There's even an external tool that you can use to design your coaster, not by hand building and placing points, but by force vector design, where you're dictating the shape of a coaster based on the forces or the accelerations that you want riders to feel. Beyond that, I don't have a lot of insight into company specific programs, but you'll also see NoLimits2 be used at competitions like at UCF in our spring design competition. We used it to kind of show a POV of our ride concept. That helped make it very clear our story, our pacing, and everything we were trying to go for. And as people are mentioning in the comments, you can also export GForce graphs. So you can get very detailed play-by-play of the accelerations that a person would feel throughout the ride. So anyway, with this slide, we were mentioning some of the coaster properties that you can set where you have different manufacturers' vehicles available in your previs or your ride POV. One other thing that's on this slide that we haven't mentioned yet is the throughput. You can calculate how many riders are going to go through your ride in 1 hour or 3,600 seconds. That's why you see that number there. And then if you know how many trains are running and how many riders are on those trains, you can figure out the total number of people going through a ride in that hour. And that can be a very common question from a business standpoint.
So these here are a couple of examples of the different styles of coaster. As I mentioned before, you can have a classic coaster, you can have hanging coaster, spinning. This one here is a wood coaster, which is obviously no limits. It does have a little bit of a different style on the way that you're going to design the structure and the supports. While all of the forces are very important, the 3 that are circled in red there are probably the most when you're thinking about your coaster. Obviously, gravity is going to pull it down. You want to keep the people from crashing to the ground. The gravity also influences how much speed you have, how fast it's going to be going, how much force is going to be applied, as well as the centripetal and centrifugal forces. Anytime you're doing a turn, those are going to be applied.
Your mic is cutting out again.
All right, I can take back over for the rest of the presentation portion. We can hopefully get that mic fixed when we do the walkthrough in our breakout sessions. So this was added as just to show that NoLimits2 has a lot of helpful plugins when designing a coaster. For example, this protractor essentially can tell you the degree of the turn that you've created. If you want exactly 270-degree turn, that can help you visualize that and create basically the spline or the path that you need to achieve that 270-degree turn. And then here we're going to talk a little bit about coaster design and more about NoLimits2 program as well. So here are a few different design considerations which we put into different categories. And before you've created a coaster, you're going to have a guest experience in mind and the theming to support that. So you'll already have an idea of your target audience, whether it's going to be a kids coaster, family coaster, or if you're seeking that maximum thrill. Maybe your park would want to, for a marketing strategy, break records in terms of height or speed. So that can also be taken into effect, and that helps you design the rest of your coaster and your ride experience with that in mind. The coaster type goes into whether you're going to go wooden or steel, whether it's going to have inversions or not, what kind of ride vehicle are you going to use. You can choose all those different options within NoLimits2. Then the rider height, again, depends on your audience. It's also helpful to know that for if you want heartline rolls, which are usually more comfortable for riders, that's usually around chest height. And so the rider height that you're expecting is going to be an important consideration for that. Then duration, guests want to make sure that the ride is worth their time. And you have a certain amount of track length in your coaster. You have a certain amount of story you want to tell. Then again, with the theming, you have the theme, which is kind of the overall message that you want to communicate to the guests, and the story, the plot events that will happen within that coaster. that maybe tie into the overall land as well. And then you also will have the visual elements with the queue, the vehicle, scenery, animated figures that all contribute to that theme and that story. Let's see. And then in terms of the technical, you have safety. Accelerations that the riders will feel is very important, and you can monitor that in NoLimits2. ASTM standards also will show what is the maximum allowable acceleration that a rider can feel based on the intensity, the direction, and the duration. Patron clearance, that's just making sure that scenery and other objects are outside of the reach of a guest or a patron. The restraints are also beyond just making sure that people are inside their vehicles. The restraints are also providing that support during braking, or when you have negative G's and you're upside down, and the restraint is what's holding you in. Emergencies and brake sections, that's just to prevent coaster collisions. That's very important, and we'll talk about it in the hands-on portion. Other questions? Yeah?
Let's see if I can try this one more time. I don't think the Bluetooth was connected correctly. So the next section could be available space. Your coaster's obviously going to have a footprint on it. If it's inside a building, that alters your coaster design. You'll have a different queue. You'll have a different coaster itself. It won't be able to be as large. You probably can't go as fast. That all falls under the available space. You also have to think about your throughput, as we were talking about before with that the one equation. Maintenance budget, that all falls under the operation. When you're building your coaster, those people are probably going to be different than the people maintaining it. You have to think about how the maintenance access the coaster if they need to get to it. How often do they have to maintain it? I believe most coasters are good for what, a 10-year lifespan, roughly, 10 to 15. However, obviously you need daily maintenance. You need to make sure everything is correct every single day. Budget, that's pretty self-explanatory. Then this last section is going to be theming. There are some pretty good coasters out there. However, they have zero theme behind them. They're basically get on it, have fun, go fast, you're done. If you've ever ridden Hagrid, one of the best coasters out there currently, it's got a great theme, it's got a great story, it's a great coaster, even if you take that all the way apart. If you go just down to the track, it still tells a story. And we'll get a little bit more into that, how your coaster can tell your story based on your movements, based on your speed, your accelerations, your decelerations, all of that stuff. Queue, vehicle, scenery, all of that is, again, pretty self-explanatory. You want it to match your story, but you don't want it to be the entire story. You want to be able to tell your story within your queue, but as well as in your ride. Then within the visual systems, that's pretty self-explanatory as well. In the land design, matching your coaster to the land that it's in. If it's something like Hagrid, you obviously want it to fit into Hogsmeade. But if it's less of a theme and more of just a coaster, sort of like Rip Ride Rocket, then it won't have as many issues being with sight lines and all of that. Everyone can hear me right? Like I'm okay? Cool. Hopefully it stays like that. Anyway, when you get into your coaster itself, in No Limits, you're going to have two main points that we're using, the vertex panel and the roll points. The vertexes are going to be all the little dark blue dots. These ones are just because of the beginning. In those, you have all of the different coordinates, the X, Y, Z. X and Z are going to be the top-down view, and then the Y is going to be how high it is. You can lock those points so that if you pull on it, if you stretch it, if you squash it, those points will stay in space, those coordinates as they are. And then if you set strict, it'll restrict the motion, but they still have an influence on how the coaster can be pulled. With a roll point, those are going to be the little green discs on the coaster itself. Those are how you set the different angles. 45 degrees in the positive direction, 45 in the negative, all of that. You can hit the no lateral G-force button, which will help restrict your Gs, prevent you from going way overboard. Yeah, those are the two main ones we're going to use. This is a mock-up or a picture of the coaster that we're potentially going to build when we do the breakout sessions, or if we just stay here. We'll make something similar to this, but we can ask you guys how you want to set it up, how you want to, do you want to do a left-hand curve as opposed to a right-hand, all of that. So talking about the points again, so we had the blue points, which are the vertexes. Those green discs are going to be the rolls. Anything that's those little red diamonds here, so the lines here, the diamonds all along the coaster track are going to be for the support system. Do you want to do this one, Cam?
All right. So NoLimits2 gives a lot of ways to visualize the accelerations that riders are feeling or how fast the coaster is going. Now, you can usually access this during the ride POV or during editing to know the exact value. But this is very good for identifying problem areas like a very tight turn. With the G-force cone, it will break down the teeth of the cone in terms of direction. Vertical Gs that you feel coming from your seat or your restraint pulling down on you. Also lateral Gs, which are very important to minimize. And then with the speed cone, as you can see with this loop, the coaster gets just enough speed to negotiate the loop and reach the top, and then it picks up speed as it goes down. Let's see, spline, that's the term for the shapes that we're working with, where you have a curve that passes through or near all the points that you set. And then blocks is referring to sections of track that should only have one coaster in them. They're separated by block breaks so that in the event of an E-stop, there'd be in one coaster only would stop. All the brakes can be engaged to stop the coasters and prevent collisions.
Typically with block breaks, the rule of thumb is however many blocks you have -1 is how many trains you should have on your track at maximum. Obviously, you can do less than that.
In other words, you should have one extra block break than you have trains.
Yeah. Does anyone have any questions so far? We've been going kind of fast. My mic is still working. Cool. So something very important when you're designing your coaster is about the forces. This here is from the ASTM 2291. This is a different, I guess, chart, different, yeah, anyway. It talks about the different speeds and forces that your coaster should be applying. So for example, in area 1, if it has a downward force, your eyes are moving downward. If it's in area 1, it has to have less than, or I guess greater than -0.2 Gs, as long as it stays within this curve, while also applying more than 0.2 Gs in the accelerated direction. They have the different areas here, as long as a little explanation. Positive Gs, negative Gs lateral, acceleration and deceleration all have their terms within them. So positive Gs are going to be eyes down. It's pushing you back into your seat. Your eyes are going back into your skull. Negative Gs, when your eyes are being pulled up, you're probably going down a hill. Your eyes are trying to be pushed up into your skull. Lateral is they're sliding left and right. Acceleration being pushed back. Deceleration, you're leaning forward.
So to go over that graph is specifically you're determining what restraints you'll need on a ride. whether you can have one lap bar for an entire group of riders, individualized lap bar, over the shoulder restraints. And that's why the areas are numbered that way. And then if you're reading the axes of the graph, then you have positive GX, or acceleration. When it says eyes back, the coaster is pushing you forward in a forward launch. But from your point of view, it just feels like you're sinking into the back of the seat because the coaster's pushing on you. That's what it really means when you feel heavy or you feel like you're sinking into the seat. And then negative GX, eyes front, is when a coaster is braking and you, like your body is moving forward, or it feels like it's moving forward because the restraints are pushing back on you. Then downward into the seat, or eyes down, positive GZ. That's usually when you're in a valley and the coaster is not only supporting your weight, but it's also accelerating you upwards into the next hill. And the opposite is true with negative Gs, or 0 Gs when you feel weightless. And then negative Gs is when the restraint is actually pulling you downward. Usually to achieve negative Gs, for 0 G specifically, you would take the same path that a projectile with the speed of your coaster would be launched, a parabolic path. And for negative Gs, the coaster is actually taking a sharper descent than what you would expect. And the restraint is basically pulling you downward.
And just as a little example on how much force it actually feels like, if you've ever been on mission space, when you're spinning, you're feeling about 2.5-ish Gs of force pushing you back into that seat. Originally it was about 4, but people were complaining, so they cut that down. But just as a reference, if you've ever been on that, that's how heavy you're feeling as you're spinning. So when you're building your curves, when you're building your coaster, you want to keep in mind how much force you're actually putting on your guests.
Then one last thing on this slide, at least from me, is that there are a few different things to consider with G-forces. There's the intensity. You don't want to have an extreme acceleration or extreme braking. Like when we say G's, that's what it feels like when you're being decelerated in terms of the acceleration due to Earth's gravity. So if a forward launch was giving you 2 G's of acceleration, then the back of the seat is pushing you with a force equal to twice your body weight. There are limits to these, and that's where direction comes in. And so vertical Gs are going to have different limits, even the upward positive Gs when a coaster is accelerating you upward, or the negative Gs when you're going over a lift hill and the restraint pretty much has to pull you down. That positive G limit is going to be different than that negative G limit. Those usually have to do with the blood rushing to your head or not enough blood reaching you because of the accelerations you're feeling. So direction really matters, whether it's vertical up and down, linear, like forward and backwards, or lateral Gs, which you typically want to avoid or minimize. You'll feel lateral Gs on an unbanked turn. If you've ever done a wild mouse ride, it's a horizontal turn, no banking, almost like a hairpin turn, where it feels like you're being thrown left and right. Another thing is that with a forward acceleration, you will be supported by the back of your seat and a headrest. But if you were to brake, you do have the restraint, like a lap bar or shoulders protecting, or shoulder restraint protecting you. But your head would fall forward. And so you look at it from a safety and a rider comfort perspective.
To answer Ryan's question in the chat, not necessarily. If they have an upper limit, it doesn't mean it's directly being applied. You could have a forward force and a lateral force at the same time, and they would partially cancel each other out. So it's not a complete 5 Gs acting on you. It could be like a 4.6 while turning, while dropping, anything like that. This is just like a rough overview of it. There's obviously tons of factors that go into it that alter how much is actually being applied.
Oh, actually, that question too brings up a really good point, and that's another aspect of G-forces is duration. If you're doing intense G-force like 5 Gs, if that's within the limits, it might be only acceptable for like a tenth of a second. The longer you feel it, the more its damaging effects add up. So maybe 5 Gs is acceptable for a certain amount of time, but usually passengers can't handle that if it's for an extended period of time. If you think of fighter pilots, they're going through even more Gs than that. ASTM is being safe with their overall limit on intensity. But at the same time, even a fighter pilot is going to pass out if they're taking a large amount of Gs for a long amount of time. And if you transition from a certain like small acceleration to a very large acceleration in a short period of time, that also kind of delivers a shock to your body. That's why we see instead of a circular loop or a circular turn, they usually have some kind of parabolic or similar shape where you kind of gradually ease into a turn so that you're gradually transitioning or gradually increasing the acceleration that a rider would feel.
Cool.
I can't speak to specific rides with that question because I don't know the G-forces available on them.
So this next one is talking about the restraint system. We had this chart up here, area 1, 2, 3, 4, 5. That corresponds to these class systems of restraint. So for example, if it's a class 1 coaster, that's going to be that minimal force is being applied both laterally and in acceleration. You don't need a restraint system on that. That'll be something like a dark ride, boat ride, anything like that, where it's very basic. It's very, you sit down, have fun. Class 2 is going to be a little more than that. You'll have some sort of restraint system on it. You're going to be locked to your vehicle somehow, but it's not necessarily going to be over the shoulder restraint. It's not going to be 3 belt buckles, anything like that. As you move up, obviously there's more types of restraint. The ride operators have their own restraint systems on the outside of the car that can be applied as well. Class 5 is when you get into the full loops, the full corkscrews, all of that stuff. You can have activation both by the user and the guest and the operator of the coaster. There's basically just look at the chart and it'll tell you what type of restraint you should be looking for based on the different parameters that they have. And this next one is also very important as well. This is based on your restraints too. If you see you have a lap bar here, an over-the-shoulder restraint here, these are the rider envelopes. This is basically the area that the guests in the seat can reach. The over-the-shoulder, they have a more minimal envelope as opposed to the lap bar, obviously, because they can reach side to side. Typically, you want to design your seats for a 95th percentile male. If you know of a bell curve, that's going to be off to the right side where the larger male can still fit in the seat and not reach any of the scenery or the other parts of the coasters. While you also want to think about the 5th percentile female. Girls are typically a little bit smaller, a little bit more petite, so they still need to fit inside the coaster without slipping out, but you need to accommodate for that 95th percentile male reaching out. Typically the, I guess, standard is if you can reach it with so 25 here is going to be shoulder grip length. On the 95th percentile is going to be 28 inches. You want to add about 3 inches to that just so you have perfect clearance. You have no issues. You have no concern that they could accidentally reach out.
Mhm. And one thing I'd add is that NoLimits2 actually has a built-in, I believe it's built in, it could be a plugin, but it has a patron clearance envelope that is just an orange ring attached to the back of the coaster so that when you're doing a POV, you can see if anything like a tree or scenery passes through that envelope. Then you know you have something you need to change and remove. It is built in. Okay.
Yes. Mm-hmm. Cool. Awesome. So before we do the breakout, is there any questions? Is there something you want us to go over again? Is there something you just didn't understand? No? Cool. So Jason, I believe we are ready to do the breakout rooms.
All right. Charlie, do you want to say your announcement?
Sure. Yeah, I've got, you may have seen this in the Discord, but I'm going to post it in here as well. We've got a new poll about a new competition that might be starting up pretty soon. So if you have a second after this presentation is done, if you could please fill out this poll so that we can get some more information about what kind of competitions are happening and what we can do in the future. So thanks.
Thank you. I'm going to assign the breakout rooms now.
So just to explain to everyone what's going to happen is Cameron and I are each going to take a breakout room, and we'll basically just go through the tutorial, practice doing that coaster that we showed before, and we can make it look like anything you guys want.
All right.
Hey, Charlie, is that the same thing that you posted in the Discord?
I believe it was, yeah.